Hey everyone, and welcome to Bytes. Today, we're going to dive into a technology so revolutionary, it literally operates on a completely different set of rules than the world you and I know. We are talking about quantum computing. So get ready, because things are about to get weird and incredibly powerful. So let's start with a big question. What if you could design the perfect life-saving drug, molecule by molecule, or create a climate model so accurate it could predict weather patterns decades from now? I mean, these are problems so colossal that even our fastest supercomputers would need longer than the age of the universe to solve them. Well, quantum computing doesn't just promise to solve them, it promises to do it in our lifetime. And this is the absolute key thing to understand. This is not about building a faster version of what we already have. This is a whole new kind of machine. We're shifting from the predictable on or off logic of classical physics to the mind-bending, probabilistic rules of the quantum realm. It's a fundamental change in how we can process reality itself. Okay, let's dive into how that actually works. To really get this revolution, we have to go right down to the very core. Your phone, your laptop, everything you're using right now is built on simple bits. A 0 or a 1. But a quantum computer, well, it has a secret weapon. Its fundamental building block, the qubit. Look at this comparison. It's pretty wild. A classical bit is just like a light switch. It's either on, which is a 1, or it's off, a 0. Simple, right? A qubit, on the other hand, is more like a spinning coin. While it's in the air, spinning, is it heads or tails? Well, it's kind of both. It's in a state of all possibilities at once, and that mind-bending property has a name: superposition. So here's the secret sauce. Because a single qubit can be both a 0 and a 1 at the same time, a quantum computer can explore a staggering number of possibilities all at once. 2 qubits can explore 4 states, 3 can explore 8, and it just scales up exponentially from there. This is where that almost unimaginable processing power really comes from. Of course, the physics behind all this gets complicated, and it gets complicated fast. That elegant-looking monster on the screen right now, that's the Schrödinger wave equation, which helps describe all this quantum weirdness. But, and this is a big but, you could put your calculator away. We're sticking to the concepts today, the what it is and why it matters. No math quiz, I promise. Okay, so just when you thought superposition was strange enough, qubits have another trick up their sleeve. It's a property so bizarre that one of the greatest minds in history gave it a very famous and very fitting nickname. Let's talk about entanglement. That's right, even Albert Einstein was baffled by this. He called it spooky action at a distance. And that quote just brilliantly captures how much this concept messes with our everyday intuition. It suggests a connection between things that seems to defy the very fabric of space and time. So what exactly is this spooky action? Well, imagine you have 2 qubits that are entangled. From that moment on, they behave like a single system. They're intrinsically linked. So if you measure one and find out its state, you instantly know the state of its partner, even if that partner is on the other side of the galaxy. It's a perfect, unbreakable correlation. Now, it's super easy to think that these particles are sending some kind of secret, faster-than-light text message to each other. But here's the thing, they're not. There is correlation without communication. Think of it like this. Imagine you have a pair of gloves, and you put each one in a separate box. If you open your box and find the left-handed glove, you instantly know the other box has the right-handed one, no matter where it is. It's a shared fate, not a secret message. For a really long time, these ideas were just, theories on a chalkboard. But for the last few decades, a quiet but super intense global race has been on to turn all this quantum weirdness into a working reality. So let's look at the timeline and see how this has all been building up. I mean, the acceleration here is just incredible. 1994 was the theoretical bombshell. Peter Shor proved that a quantum computer could, in theory, crack the encryption that protects our entire digital world. Huge. By 2001, we had a tiny proof of concept, factoring the number 15. Then jump to 2019, and bam, Google claims quantum supremacy, doing a calculation in minutes that would take a supercomputer 10,000 years. And just in 2023, IBM blew right past the 1,000 qubit barrier. Which brings us to right here, right now in 2025. This isn't science fiction anymore, not by a long shot. We've officially entered the quantum era, a specific phase of development that even has its own name. Welcome to the NISQ era.
That stands for noisy intermediate scale quantum. And honestly, it's the perfect description of where we are. Our quantum computers are incredibly powerful, but they're also really delicate. They're susceptible to errors or noise from pretty much anything in their environment. So they're not perfect yet, but they're already big enough to start tackling problems that are way beyond the reach of our best classical machines.
And this number just brilliantly illustrates the scale we're already at. In late 2023, Atom Computing built a machine with over 1,100 qubits. These numbers just keep climbing, and they're climbing faster and faster. The hardware is here, and its power is growing with every single qubit that gets added. So we've gone from a spooky theory to real 1,000-qubit machines sitting in labs right now. The quantum revolution isn't coming. We're living in its opening act. The question is no longer if this is going to change our world, but how. Are we ready for what comes next? Thanks so much for joining me on this tour of the quantum realm here on Bright Bytes. If this helped you wrap your head around one of the biggest ideas in science today, do me a favor and hit that like button, subscribe, and maybe share it with someone else who's curious. We've got a lot more explainers on the tech that's shaping our world coming your way soon. See you next one.